I know most of you are in computer science background. Guys, come on, respond. All right, it's up to you if you want to answer the questions and make it interactive session. I don't care, but let's start. So till last week, right? So we completed with the Linux. So it's like overall, right? We discussed what is Linux, why to use, and different commands and the basics of shell scripting we completed, right? So from this session, so it's all about database. So the actual data engineering will start from here. So make sure you get all the things what I'm saying. If you don't understand, raise it and ask the question. Okay. So if you don't ask questions, so it's uh, you will lose that opportunity to learn more. Okay. All right. So let's get started on the SQL. I mean, see, uh, I'll put expectations on this course. So at the end of this SQL uh, training, right? So you would understand how to write the queries. So it may be a simple query, it's a complex one, joins or group by analytical functions or a window functions, anything. Okay. So we will cover all of this, but we will not cover anything on DML or DDL. It's not that much important, but I'll give you an overview, like I'll take an hour or more to explain that DMLs. DML something but how to insert, how to update, delete data. But we will discuss that, but I will not go in depth on that. But mostly our intention is to get more knowledge on the select queries. So how efficient we can query the database and get the data from the tables. Okay. All right. So any questions on this one, or you are expecting something else? Okay. So here is a question. So before getting into all the things, right? So I'll ask you a question. What is data? We will be talking more on the database, data processing, right? Collection of data. Everything is on data. But exactly what is data now? Come on, guys. Don't be silent. It's Monday. Uh,
Data is data is nothing but the storage of details about something or someone.
okay.
Maybe um, so maintaining the history of what is some more details about the company, example,
Hmm?
some more detailing about company like what is uh, maybe let's take an example of the company storing employees details and contact numbers, personal details like that. It is called data.
Okay. So you are going too much forward. So my simple question is, what is data? And you are saying is all about database and everything, right? Right.
Data,
You are
yeah,
giving in on your answer is in that context. I mean,
yeah.
so a broad one. Yeah. That's also right. Yeah. Others, I mean, like Sidhu or Subbareddy, Monica, Raghunath. What is your perspective on the data? Okay. So data is nothing but just an information, right? Small unit of information or anything, right or not? So basically data is, it's information or which you can give in a piece of paper, you can write it, or we are teaching class, right? Or recording it. It's an information or data. And whatever you see in images or videos, everything comes into data. Okay. So it's like, data that can be stored in a paper or electronically, whatever it is. But it is has some meaningful information, that is data. But when you say meaningful information or a systematic, that's called information. Confusing, right? Piece of information is called a data, but what is information here? Information, nothing but it's a meaningful data basically. So interrelated, right? You will be writing some text, with many grammatical errors. You call it as data, but it's not information because the people who are reading that sentence, they must understand it. Then only that is meaningful, and the other person who is reading that, he can get some knowledge on what you are reading or you are giving as an information, right? So as overall, data is nothing but information which can be stored in an electronic manner. Maybe it's like our computer systems, or which can be written on paper. Okay, and then, but you know, uh, why do we call this information? But when it comes to computing, so we call it as information, okay, because we store them electronically. Okay, and again, so why this database come into picture, right? So we can simply store data on a file and store it in your file system, right? But why we have this database instead of file system and everything? Am I right or wrong? So you have around maybe more than 500 GB database, disk in your laptops or PCs, and everyone is having at least 250 gigabytes, right? You can store everything, keep that in a file and store it in your system. It's very simple. So no software needed, nothing is needed. And whenever you want, you can open and always read it, right? But again, so why do we have this databases and everything? Why you are learning all this? Can anyone answer this question? Guys, if you are silent like this, right? So if you don't ask any questions, I'll just go on my flow and finish the class. Is that okay for you? It's up to you. Okay. And let's simply teach and leave. So there is no wrong answer. It's only you're trying to give your best. It's okay if you given as a wrong answer. That is all completely all right. You know, if you don't speak in any meetings, right, like this, let's assume this is a meeting. If someone asks you a question, you should respond. If you are being like this silent, right? So in the future as well, when you are in an actual meeting with your team, so it's, if you feel hesitate to talk, so it's not good. At least if you talk now, so that will get like a habit. Asking questions and being interactive, right? So try to be that way. Don't be silent. Okay. Try to speak and interact, ask questions. Okay. Let me share my screen. Can you see my screen now?
Yes, sir.
Right. Okay. So from today onwards, we'll be talking about database. Right. So what are we talking? Data, right? Is it visible for you clearly?
Yes, sir.
Yeah. Okay. So we can say it as a small unit of information or right. Right. And then, so what is information again? It's like meaningful data. Anything that is meaningful. Otherwise, I don't want to reuse that data again. So it's like a circular again, right? Anything that is meaningful to understand, right? And again, we should be see these are all I'm saying in my words. If you go and look in internet and you'll be seeing different definitions. So everybody will be having their own perspective, right? So don't come back to me and this is a definition in the internet and the like. But that's not the way. Just try to understand the context and go with that flow. Okay. Grammatical, I would say. Grammatical. So that it's meaningful. Then in that case only that's meaningful, right? So whenever we store something, we write something. So there should be no grammatical errors. Then only the other person can understand it, right? So again, so we just started with the data and so the context is we need to understand what is database and why do we use that, right? So then only we'll be knowing why we using this SQL and everything. Now, so what is database? So database is nothing but it's a collection of data. Okay, it is a collection of data and which explains so one or more organizations. But again, how that is relevant? Why it's only organization? Why not is something else? So I would use instead of organizations. So I would say any subject. I mean,
Hi guys, due to power cuts, I will be joining few minutes. Wait for some time. Guys, let's wait for a while up to 9:30. So if he's not able to join, we will wind up the call. Okay. So we will conduct for tomorrow this session.
Okay.
I am back. Can you all hear me?
Yes.
Yes, sir.
Yes, sir.
Yes, sir.
Okay. So we were talking about a database, right? Let me share my screen. Right. So what I was saying, what is database? So database nothing but collection of data. Okay. And I am saying which explains one or more organizations or a subject. Why like this? Why it's only explains organization, why not something, right? Yeah, it explains everything. Depends on how we design it. Okay. So there are people called data modelers who will design the database, and we will be using the databases to insert or retrieve data. Just a minute, guys. Sorry for that sound. I closed all my windows and everything, but it's still that way. Okay. Right. So database nothing but it's a collection of data. So which explains an organization or any company or any business basically. Okay. But how that helps, right? That's a question. So for example, if I take a company, right? So any small or big, any size, whatever it is, right? So let's take an example. Uh, let's say Google. Okay, it's a company basically. So everyone knows Google, but to make all those products, right? So Google has its own employees, right? Its own departments, and the people are getting paid for what they're doing, right? So everything they'll store somewhere, right? So where do they store? They store in database. So let's say, so in that case, a company, right? When I say company, an organization, so they have employees, right? And departments, their products, right? Or projects they are working, and their payroll information, everything, right? So when I say database of a company, so it must be having all this. So there are many things that I'm not listed here, but it's just an assumption or understanding purpose. We are using just very few. Okay. So now, how do they store all this? I mean, like employees information or departments or their products or something. How do they store? So when I say the people, I mean, a company stores information in database. So they store all this information in form of tables. Okay, in the form of tables, right? So again, I'll come back to this again. So what is database? It's a collection of data and which explains one or more organizations And again, so how it helps, right? I mean, as an example, I took an example of a company. Maybe it's any other company, like I said Google, okay? But this Google company, right? It's having its own employee database. But it's more when we look at the products, right? So let's take a product like Gmail. So Gmail is having like millions of users, maybe close to a billion, right? So that is separate actually. So when I'm talking about only the company, so this comes into picture. Even right? So when you are joining a company, they'll be having their own employee database, right? So again, so how do they store in a database? So they store everything in the form of tables. Table is the actual data store where it holds some data, right? So again, uh, right. Again, what is a table? What is a table? So table is nothing but combination of rows and columns. Am I right or not? Is it right? You must be know about Excel sheet. It's nothing but a tabular form, right? So you'll be having some columns and then rows, right? So again, what is a column and what is a row? Anyone can answer this question? This is very straightforward, so no need to think about it. It's okay if you are saying something wrong. That's completely all right. But should answer this question. Okay. So column, it's a, let's say I'll call it as a metadata. This is actual information in my terms, okay? So why I am saying it as a metadata when I say column, and the row will be storing actual information. So why? Let's take an example. Everyone know, right? At least some knowledge on the programming. If not, so listen here. Why I'm calling this as a metadata. So let's say I'm taking an example of, I'll open Excel. So if I take employee table, right? Okay, let's use this. I'll go to this and I'll open, right? So now this is a employees table, okay? And this is a column name, right? So there are 11 columns within this table. Okay, what it is telling us, so it is having data type, whether this column is nullable or not, the default data and the column ID and the comment, right? So, but if you see about this table, do you see any data or it's just only information about this table, right? You only see the information about this table. So what are the columns in there and what is the data type that is using, the other information that is needed, right? So again, why I'm saying this as a metadata. So metadata nothing but it's a data that explains data, right? What it is explaining us. Come back here. So when I say employee ID, what it is saying, this is a primary key of the employees table and this is not nullable. And this stores only number values. So this is called metadata, which is explaining us what is this employee ID will do in this employees table? Am I right? Are you following me? So two things here,
Yes, sir.
data and then metadata. Metadata nothing but data that explains the data, data about data. Okay, anything. So if I take employees, for this employees, there must be something like, you'll be saying, so employees table is having 11 columns and it is having uh, fewer, I mean, there are some primary key and there are some unique keys. Okay, this all information that is explains employees table. That is a metadata about employees. But when it comes to the each column, so again, this explains what it is storing and what is the format and what is the description of this. That is a metadata. And again, if I come back and query it, right, you see some data here. Now, these are rows, okay? Whatever that I am highlighting, these are rows, and this is a column, rows and columns. The combination of rows and columns that gives us a table. Clear this concept? All right. So now again, so you must be, learn about this RDBMS. Before that, we'll get into DBMS. So, so far, right, we talked about data, then database, then how do we store data in database, that is tables. And now we came to DBMS. So then what is DBMS? I know 2 or 3 students are here from computer science. They must know what is a database management systems. So this is a database management systems, right? So can anyone answer this question? So it's very simple, the name itself it's saying management. So it is a specific, specific software, or there are many versions of it. You know, we are using Oracle for our training purpose, but there are many other databases in the world. Okay, so it is a software again designed maintaining database. Simple. So software designed for maintaining a database. It's very simple to say, but there are many, many responsibilities comes with a DBMS. Okay, so I'll list a few. So it's like query processing. Okay, so what I was doing here, select star from employees. What does it mean, right? So basically we are using Oracle database and we use this Oracle SQL developer, which is kind of an IDE. IDE nothing but integrated development environment specific to SQL, and which comes with many loaded features so that we can simply use those features and write SQL queries or PL/SQL programs. Simple. Okay. But again, so how this works in the background, how this will be executed? It's a question, right? So this everything, these kind of things, right? Query processing. So this is backed by the DBMS again. The DBMS nothing but it's a Oracle that we are using. There is a query engine that will pass this query and then optimize, then read the stats and then give us a execute it and then give us a result. We'll come back to that again. But that is one thing part of our DBMS systems. Okay. Again, so performance and user management and security. Okay, so it's like many other features. Okay, that a DBMS will provide. So if I say it's Oracle only that we are using, or any MySQL or SQL Server, that's by Microsoft, right? Everything. All are comes into a database management system. Okay, and everything it's having their own features. Okay, right. So again, so what is DBMS? So DBMS nothing but it's a software that is designed to maintain a database. Okay. So again, so why do we use this DBMS? So depends on the the scale of organization. Maybe it's a small or big. So the size of the database is very huge or very small, right? So the DBMS will help us to organize or utilize these features, and we can maintain the database very easily. Okay. Again, so you must be hearing something about if you are from software background or computer science background, you must be knowing about RDBMS, right? This is relational DBMS. Again, what is this? See, I'm just giving you a different concepts when it comes to databases. Okay, these are all things not really required, but you should know at least basic things about database, right? So again, what is RDBMS? So, I mean, it's nothing but relational database management systems. But again, why we use this? See, most of these databases, right, are relational database management systems. Why it is or why we use this, right? I'll give you a simple example. I'll take an example of Zomato because this everyone knows this Zomato, and we use this to order food online, right? So what exactly we do with the Zomato? So we log in and you are starving and you'll just go and order something that you like, right? And you may order maybe one order at a time or two or three foods at a time, right? Right? So there is a relationship here. As a customer, you will place order, right? So or more than one order, right? Now one order, right? So when I say order, one order cannot be placed and then orders we have. So now what Zomato people will do, they store this information in their customer information, customers table. So what this table will be having, so it is having details like customer name. So I'll say customer is a table now. It will be having name, maybe age or contact, then address. Okay. So if you give any landmark, so near to your address, it also have a landmark. I'll just simple. Okay. And the order. So, and here the one more thing is it will be maintaining a unique ID. Let's say customer ID, right? Now order will be having order ID. and customer ID and the product size or quantity, and here it also having billing information as well. In the customer will be having billing information again. That's separate. Okay. So now what is the relationship here? Let's say I ordered something. I placed on biryani or something else, right? And that will be stored in the customer's table. And then the people will look at the orders and they dispatch it, right? The delivery boy came and will come and deliver that food to you at your doorstep. How is this organized basically? So when people are looking at the orders, so they will look at this information, customer ID, and then they pick up this customer and they look at the address and their billing information, then they'll dispatch it, right? So now, what is the role of relational database management systems here? So it created a relationship here between customers and orders. So if there is a customer that orders something, so we can simply go and search with the customer ID in the orders and you'll get the details, right? So if there is nothing that can connect these two tables and people will not understand what a customer ordered for. Okay, if I remove this, right? And if I only storing order ID in this orders, and how do I identify which customer order, which food, right? It's very hard for us to understand, right? So that is the reason. So all the databases are maintaining this relationships in the tables. I'll show you with an example. Even, this employee table that we opened, it must be connected with some other tables here. You know, these are employees, their job history and the HR jobs, what is connected with and the department that he belongs to, right? So overall, it created a model here. Okay. So basically, when there is a relationship in the tables and by default, there will be a model created. But in general, when we are creating a project or if we wanted to start on a project initially, data modelers will come into picture and they'll identify the tables and the relationship between these tables. Okay, right? So relationship nothing but how the tables will be connected. Or again, so how the tables will be connected, right? So that is the reason if you see there are, PF, PFF, right? So let's see what are these. If you go to columns, right? So anyhow, so this is a primary key and a foreign key, and this is a foreign key. So let's come back to this. Are you clear on this DBMS, why we use relational databases? Before I jump into that. Very simple to understand. So
Yes.
yeah, so the relationship between the tables, so that will help us to create the model. And with the model, so it will be very efficient to query the tables. So you will understand so how the tables are connected here, right? So if I wanted to find out, see for this, let's say there are multiple departments in the HR departments, right? So departments. So if I wanted to find out, so what is the current job of an employee ID? So and what is his current department name, right? So you can just simply combine these two tables and you can extract that information. But if you don't know what is the relationship between these two tables, it's will not be able to do that, right? That's why most of the database systems are RDBMS. I mean, they're relational in nature. Right. And again, so I was telling you, I'm telling you, so the relationships, right? So how many ways that we can connect these tables, right? So the relationships, so we can explain in these ways. Basically, it's one to one, okay, and one to many to one, many to many. Think, Girish, can you explain at least once? Maybe you already worked on Informatica, right? You must know at least these things. Any idea?
Yeah, I know. I know, like still, but one to one, one to many, many to one, many to many. This one,
Mm.
this was the first time I'm listening to.
Okay, I'll tell you.
Uh, this, like a
All right.
plus into plus minus.
Okay. If I take this as an example, okay. So I have employees and departments, right? One employee can be working for one department. Am I right?
Yes.
Yes. This is one to one. But in reverse, but one department must be having many employees.
Many, many.
So then from departments to employee is many to one. Sorry, one to many. From employees to departments, it's many to one. So it's like many employees can work for one department, and from there onwards, it's many to many again. Let me give you clear examples for one of everything, right? So I don't want to confuse you with right. Okay, I'll ask you one question. So how many passports that you have?
How many?
How many passports a single citizen
I
will
have
have?
one.
One, right?
Yeah.
And one passport belongs to one person. Am I right? A passport is given to one citizen, and a citizen will get only one passport. If that is expired, he will get a new one. Again, that is the only one that is active. So it is an example of one to one, right? Are you clear? Either way, so even you give a passport to many people, it's not possible. Only one people. That's on your name. One on one, that's it. I will be having only one passport, and that passport is belongs to me. That's it. That cannot be used by any other person. So it's simple. And one to many. Yeah. So I was telling you, right? This Zomato order. So a customer can place multiple orders. Am I right? Even if I go and order something on a Zomato, I can give order for anything I want. It's not limited to one, right? I can place many orders. But one order, right, that cannot be placed by two people. Either you place it, I'll place it. But we can't do it the same time. We can't do it together. Am I right? Clear?
I didn't get this one. Could you please give it a second? Right?
Your voice is not the clear, man.
I think I didn't get the last one. Could you get put this way back?
You don't understand one too many?
Like you told Zomato orders, right? That's one.
Right. See, let's say I can place any number of orders. right, as a person at the same time or multiple times. But this order, let's say I placed as a customer 1, I placed order 1, order 2. Okay. So now what is the relationship here? One to many, right? Only
One
one
too many.
customer placing more than one orders, right? But if I select this order, can it be placed by multiple people? No, right? One order can be placed by one person, but one single order cannot be placed by two persons or more than one person. Am I right? So this is an example
Yeah,
of
yeah.
one to many, but it's not reverse. An order is an order, but placed by one person. But I, as a person, I can place many orders. This is one to many. Got it?
Yeah, got it, sir.
Okay. Now it's many to one. Any example in such case? If you understood one to one and one to many, so it's very easy to you. Give a simple example for many to one. It's very simple. If I take a students, then college, right?
Yeah,
Many
students
students
in
can
college.
attend one college, but right? Simple. And many to many, I'll simply say employee and projects. See, I know, so there must be cases or, you know, there are some situations one employee or many employees will be working for multiple projects or multiple projects or a project will be having multiple employees. Either way, many to many. Maybe I am working for a company, I might be working for two projects at a time. That is many. And projects, right? Each projects will be having at least few persons, right? It's many again. That's simple actually. So these are the different relationships that we basically observe when we define or design a data model. But you know, these are all information purpose and just keep in mind. All right. So now we understood simple things. What is data, database, DBMS, RDBMS, and relationships in the types of relationships. I mean, in RDBMS, and then uh, again. So what do we do then? So we learn all these things. What is next? How this is designed? See, when I say database or DBMS, just both are same. If I don't use this RDMS more frequent, but you should be careful. See, the SQL that we use, it will be used as a same across the different databases, but depends on the flavor. There may be a minor syntax differences, but the overall concepts will be 100% same. And you know, this ANSI standard SQLs that will be same across all the different databases and will be following the same most of the times. Okay, so right. So what is the architecture basically? We'll talk about this and then finish the class. So what is the architecture of data storage levels? I mean, so yeah, I would say the storage. How do we organize this basically? So I'll don't talk about this architecture. It goes in the different dimension. So how do we organize data basically? Or tables? right? So basically there are something called abstractions that we call, okay? So whenever we organize this data in form of tables, I would say physical, logical, and views. I'll do one thing. I'll put this at the end. Okay, right. Why it is physical and then logical, then views. So physical, nothing but the actual data that is stored in a physical manner. These are tables. Okay, right. So we have tables, and then what is this logical and what is this views? So logical, nothing but which describes the relationships. See, we will not be discussing deep on this, just informational purpose again. Okay, logical describe the relationships in the database. And views, you know, this is mostly used as a security purpose. So it will hide actual information like metadata. Okay, and only allowed people can view the data. So we'll discuss this maybe views. Okay, physically, or we'll discuss on this one because we use views in some cases. But again, so how do we describe this? So whenever we create a database, we identify all these things. As a first thing, what are the tables that we need to create? So let's take an example of a university. Okay, so a university must be having students and professors and some other staff, then courses and the classrooms, and the lecture schedules and all these things, right? So when we think of all these things into picture, I mean, take them all into picture. So we will decide how to create a database, right? So we identify the entities or tables. So we'll be creating one table for student, one table for professor, one table for schedules, and the other table for departments, because we'll be having different departments even in that university, and then courses, and then we identify how to connect all these tables, right? So otherwise it will be very hard for us to, let's say I wanted to schedule a lecture for tomorrow. So how can I do that if there is no relationship identified in the tables on the fly, right? So that's the reason they will create this model, entity relationship models, okay? And that comes into the logical things. So which will describe the relationships in the TP, nothing but see entity relationship diagram they will prepare. So okay, when we design a database, first we identify the tables, then we come to the logical things, like how do we define the relationships, and they'll create a clear diagrams, and based on that they'll create the tables. And again, what is this view? You're clear, right? What is a logical thing? Clear or unclear?
Yes. Yeah.
Okay, great. Then views. So let's say I'll take an example of a bank, okay, and bank must be having bank customers are savings accounts, deposit accounts, current accounts, recurring deposits, loan accounts, many things basically, right? So in bank also there are different departments. They will be using the data that's stored in the databases or tables. and they'll do some analytics. Okay. Now I am from a loans department. Some other person is from deposits department. Okay. As a loan departments person, I should be only accessing the loans data. And the other person who is working in a deposits, he'll be accessing only deposits data, right? But the table is having all the data inside. How do we enable the access to the people in that case? So in that case, what I will do, right? I'll create a view. Okay. I'll create a view with the columns that a specific person needed or specific department needed, and I'll give access on that view to that department so that they can only query the data that we are exposing, not the table. Okay, it's like this basically. Let's say I have a table here. This is a table and having a different columns. Okay, let's say I'm just having, let's assume these are 4 columns here. Okay, 1, 2, 3, 4, and I have 2 departments. They wanted to use this table, but they need to use only the information they wanted to use, right? So now what I'll do, I'll 1, this is 2, maybe it's like, what I'll do, I'll pick these 2 columns as a select and create this view. And with these 3 columns that this department needed, I'll create this view too. This is 2, this is 1. Okay. And these views, right? The people will query these views instead of querying the actual table, which is having the whole personal information or confidential information we are not exposing. Using views, we are exposing the data that is exactly needed by the consumers. So basically views are nothing but a secured objects, and they will allow us to access only information that needed. We will discuss this during our classes, how to create a view and how this will be used. But this is a way when we design a database. So we'll identify the tables, then the relationships, and then how to expose the data into the consumers, mostly the tables, I mean views. Okay. But if you go in the deeper, so there will be like a row level security RLS or a column level masking. So it's very advanced concept, but I will not be talking them. But again, so this is overall about a database. Okay. Any questions in today's class? The topics that we discussed. So again, we discussed data and database, DBMS or DBMS, and relationships, and see the design. The overall, I mean, you must know how do we store data in form of tables, and what is data, database, DBMS, RDBMS, relationships, and design. Hope you are clear. If there are no questions.
No questions.
Okay. So tomorrow, so we'll start something on how the queries will be executed, and then we'll get into